Good morning. This morning we're going to simulate a Nationals teardown of a Model 80 Yamato that would be competing in the 20 SS class. For this demonstration we are going to say that the motor has cleared preliminary inspection, that is, seals, the fuel requirements were met, propeller configuration, and all the other things for preliminary, and fuel were done. At this point we will start the primary inspection process by inspecting the gear case first. First of all, in inspection, the driver, owner, and mechanic are the only three parties other than the inspector that's allowed into the inspection area. The inspection area is not really a spectator area or spectator sport. It's to be confined because there is proprietary information involved. The first thing we will do is check this motor for the gear ratio. I have a gear ratio template that I use. There's various ways you can inspect the motor. This is the way I do it. I'm not saying it's the only way. Now the next thing we do is rotate the power head till we get it up the pointer to 0. Now we're going to stand up and we're going to put 2 marks on the flywheel, the rope shift rather, to give us a start-finish point. We'll rotate the power head 1 rotation. And if you come down here, you'll see the indicator points for a Model 80, which means this gear ratio is in compliance. This is a Mylar template that we use to denote the Z dimensions on a Yamato gear case. There's 4 holes. I'll line this up on the skeg and mark it with a pencil. This is an 0:1 micrometer. It is now set at 185 thousandths, which is the top 2 Z dimensions. As you can see, it won't even go on. That means this gear case is well within specification. Now I'm going to rechange this to the next dimension for the lower. The other dimension's 130 thousandths minimum. So we'll go back down here to 100. And there's 130. Again, the micrometer will not slide even close to the holes. Means this lower unit is within spec. The next thing we will check on this lower unit are the radiuses. One is on the, I call it the bullet. We use a radius gauge that's in the tech manual. Can you see past my hand? You can see that the radius is really fat. This has never been worked. This is well within spec. The smaller one is here. And again, you see it fits really nice, the whole length. To where it doesn't fit, it's actually fat. So this upper radius is within spec. I have a digital micrometer that's actually used for checking brake rotors, but it works really nice on doing lower units as well. And this is set for the upper dimension. As you can see, it goes so far and stops. That means that part is within specification. I'm going to reset it for the second spec. And now we'll try the strut, try the bullet. And you can see there's definitely a fat spot there, so the bullet is within specification. For the dimensions we've done so far, what I do is I check various spots on the lower unit. It's not a finite one spot where the unit must meet spec, but it's pretty much its entire distance, so that you're not trying to pick up a single point. This is basically a stock class, and it's the top of the parameter of the tech manual tells you that the motor is to be raced as it was received from the factory, with modern modifications allowed by the Racing Commission. If any time that a gauge or a tool slides past, this will tell you that the unit is illegal. The other thing that's important to note is all these dimensions are what we call proprietary. In other words, a motor builder has built a motor to a specific specification. It is up to the inspector to determine the motor is within specification, yet those specifications are not written down or recorded. You just physically check and say this motor is within spec. What you're doing, number one, is determining the motor's legality for the first place winner, but you're also telling the rest of the field that they got beaten by a legal motor. Dimension we will inspect will be what they call the cone length, and use a couple tools here. We'll put a straight edge across the back of the cone, and I'll set this in place. You can see that it goes beyond it, so the cone is definitely long. Try that again. See, it's way past by the time we hit the dimension, so that makes this within the spec. The next dimension we'll try and check will be what they call the cone diameter. Again, where you use the deep-throated dial caliper. Slide it up the cone, and you can see it sticks. Can try it a couple different ways. Those two dimensions are within spec.
What are you doing now, Jeff?
This is what I have. This is a worksheet that we use in a teardown for a nationals or a record run. It's a sheet I use as a check sheet to make sure I don't miss any major dimension. And I'm going to fill it out now because we have some dimensions as far as just the basic things. Again, you don't record dimensions, but we record the compliance. The next thing we will do is we will CC the motor, and the first thing we'll do is we will zero the barrette. We have a barrette here that's filled with fluid, and right now it is overfilled, and it's been sitting for a while so that we have all the air bubbles out of it. And as you can see now, it's way over the zero line. And that is pretty much zero at that point. Okay. What we have is we have a barrette filled with fluid, and you can see there's a radius in there, and that is the meniscus. And you use the bottom of the meniscus to the top of that zero start point, and that basically zeroes the barrette. We remove the spark plugs out of the motor, and now we're going to try and get the cylinder head in a horizontal plane. And I have a small bubble level that we will use to determine that. Okay, that's not too bad that way. A little bit more down, or I should say we got tweaked this way, I think. That's pretty decent. We'll stay there. Okay. And we're good that way. I'll set this just up here so we can keep track of it. I'm now going to take an object, a thin one. We're just going to slide it down inside the spark plug and try to determine top dead center. Right now, this can be done as a rough setting. There's no need to get precise right now. Just get it close. See, there's low, and there you can see it coming up to TDC. Because this is measured at TDC, and you put enough fluid in to fill the combustion chamber plus the spark plug threads right to the top of the hole. When we hit flush, that will be the CC of the motor. What we'll do right now is we're going to try and just put oil in the bottom of the cylinder until we get the oil to the bottom of the threads, and then we will rock the cylinder to make sure we are then at TDC. Okay. We've rocked it, and now we'll continue to add some fluid as the oil comes up the spark plug holes. We'll stop there, double check, and we'll finish adding the fluid. We record our dimension. And we'll also let this sit for about a minute and come back over, because as the fluid runs down the tube, there'll be remaining oil on the walls. So you give it a chance to catch up, it'll pick up about 2 to 3 tenths. So we'll actually get our actual dimension in about a minute. I call the mechanics helpers. It's nothing more than a $1 turkey baster and an empty bottle too. We're going to try and remove the bulk of the CC fluid out of the motor so we don't get a mess later. We ended up with a CC measurement of 19.5, and if you look in the tech manual, with a 14 millimeter head, minimum combustion is 18. This engine's well within spec. Couple of notes. When CCing a motor, if the engine is, I'll phrase it this way, well within specification. I usually only CC one cylinder, as this one was. When it gets within a couple to 5 tenths of specification, then I'll CC both cylinders. This Yamato has a hemispherical head. So basically, if you set the engine up horizontally, and you can add fluid till it comes out the spark plug hole. Makes it a relatively easy, straightforward process to CC. The two most difficult motors to do are the OMC-A and the Mercury 15 because their spark plugs are on an angle. That requires at least 2 to 3 people. 3 is preferred. One holds the flywheel in a stationary configuration. Another person holds the power head, and the third person does the CCing. And in that process, you would put the engine initially, as we did here, in a horizontal position with the spark plugs being on the angle. And again, you'll put fluid in the cylinder until you put fluid to the base of the spark plug holes, approximately 1 to 2 threads up. And then you will stop and start to rotate the block motor assembly so that you're going to ultimately end up with the spark plug holes being horizontal and the motor being on an angle. What you'll do is you'll add some more fluid, stop, and then we rotate the flywheel very slightly to make sure we've, as the saying goes, burped it, to make sure there's no air bubbles caught in the corners of the combustion chamber. At that point in time, we will finish filling the motor with fluid until we hit the top of the spark plug holes, and then see if the motor meets compliance. It is definitely a unique motor to CC. What we have here is a digital dial caliper with a custom-made adapter on the lower end of it. So it actually will thread into the spark plug hole. This makes doing stroke, which will be our next dimension, relatively very easy. On some motors, you're forced, like I was talking about the OMC motors, you're forced to do them with the head off, and you have to use T-block or some other configuration to get your measuring device in a position to be able to do stroke. This one will do this way. This one should be down. Okay. We're going to use the number 1 spark plug hole in this case because we have number 2 hole to TDC because we just CC'd it, so we know this cylinder is down, so it gives us a good place to start. You thread the dial caliper with its adapter tool into the spark plug hole until we get it fairly just snug, just so it stays put. Okay, the next thing we'll do is turn it on, and then we will slide the dial caliper down the hole until we hit bottom, and then we'll rotate it about to try and get the highest number we can read, and that looks like we're here. Then what you do is you 0, and then we will finish rotating it the other way. And when we get to the other end of the stroke, it will give us a dimension. Okay. We've now measured the stroke, and we will move forward. Usually at this time I instruct the mechanic to remove the silencer cover, the gas tank, bracketry, etc., so we can keep going further forward.
He was doing restrictor plates. He was going to do something else.
Okay. We need.
Go off and
Okay. put in the pub.
Yeah.
Need something? Yes.
Number 13. Then people will be improved in the inspection area.
Well, that said, if you wanted your foot to measure, go get one.
Trying to go up. The pump is carburetor. As far as inspections, probably what works next.
Well, we can't get the exhaust manifold off.
During this process, while the mechanic is disassembling the motor, it's not like he is needs to be necessarily watched by the mechanic or the inspector in charge, but we usually have what we call a watcher, and the watcher will keep an eye on where the mechanic is going so he doesn't remove components further than the instructions given by the motor inspector. Does this have a dimension on it, TJ?
What?
The rope shiv on an 80. There's a one or
There's
two.
a weight.
There's a weight, that's all.
Weight.
Okay.
At least I think there's a weight. The 80s, there was a lot of stuff that wasn't.
I think this is one of those ones that's just missing. That's a flywheel. That's a flywheel. That's not good. I don't think the rope shiv has one. I think it's one of them deals.
So in that case, we just compare it.
Right. To all the big races I take. And that's this. I always compare the water inlet holes in the Yamato. I feel that's more critical than anything else. To see if they've been moved.
Surely no one would do that.
Surely, surely. No. At this point in time, he's removed the first component that we'll stop and inspect. This will be the carburetor. We'll see if we can measure the butterfly, the throat, and the venturi. You also look at to see if it is the carburetor that belongs on the motor. Peace. Okay. Let's see. Venturi, 84 and 15 makes 99.
You're gonna measure that carburetor venturi.
We now have the carburetor off, and the first thing we will do is measure the venturi, and that's done from the front. You can look at it right here, and I have a set of dividers that I have preset to the maximum allowable size, and we will slowly put them in the carburetor to see if it'll go in. In this case, they won't. They're stopped, which means this venturi is within specification. The second dimension we will do is they have a butterfly thickness. We'll go to the back of the side of the carburetor, and we'll open the carburetor to wide open, and we will get a dial caliper, and we can go in here and measure this. And I've pre-looked up the dimension. This dimension is well within spec. The other thing we do is you look at the carburetor. At this point in time, we start going inside the motor. Visual is very important. You have to look at it and determine, it's called as cast. You're looking for machine marks. If you look in this one, all you're going to see are the factory machine marks or the as cast marks. The same with the front. This has the plastic factory horn. If you look inside the venturi, you will see that, and down the barrel of the carburetor, you'll see that it is as produced as the manufacturer. I'm satisfied with this carburetor. Next thing we'll do is look at the intake manifold. And here we have the intake manifold loose and is ready to be given to the inspector. And we'll stop right here and leave the reeds in place. First thing we do is look at the intake manifold, and you can see this one is as cast. You can see the rough finish. Okay. So at this point, we'll turn this part back over to the parts, and we'll look at the reeds next. We'll walk over and start measuring. Okay, and the biggie is Q, I think. Okay. Here we have the Yamato reed back in our hand, and we have a dowel caliper set at the maximum opening dimension. The thing that's important about in doing this is a Yamato reed stop, which is this, at the front edge has a radiused corner. They're not sheared sharp. So to get the dimension, you have to go the tangent of the radius and the underside of the reed stop to pick it up, and you just slightly depress down on the reed cage and you slide in. And you'll see that that one just barely goes underneath. So this one we have a problem with. And you measure the next one, and you'll see it stops. That is a perfectly set. Turning it over, it stops, and the back one stops again. So on this one over here, the very first one we checked, you can see that it slides underneath. At this point in time, we'd have a problem. But for this exercise, we're going to continue. Now I'll have the mechanic remove the reed stop from the reed block. He's just a screwdriver, and he'll remove them. And then what we're going to do is we'll measure. We're going to look at the holes. From the other side, I also now can measure the stop length. And here we have a disassembled reed cage. What we have removed a set of reeds from the reed block, and these reeds are within specification thickness-wise. That's all there is a thickness on the reeds themselves. They slide right in. So we're okay there. The next thing we would do is pick up the reed block and visually check the reed hole opening. This is a neoprene seat. It's difficult to tamper with, but you look at it visually to see if the corners are nice and sharp, and it looks like they haven't been tampered with. Here we have also the reed shim. Some motors have a shim, some motors don't have a shim. It seemed to vary on the year and the production run. Just one of those things, after years of doing them, you know to look for. Next thing we're gonna do is turn this over and we're gonna measure what we call the stop length. What we're doing now is measuring the stop length, and you find as best you can the center of the stop screw, and you set it there to the edge of the reed stop, and you come up with a dimension with a little bit of twisting, and then you go in and check this reed stop. I've already checked the dimension and is within compliance. What we would do is we now would inspect the second set of reeds, but we're going to move on for sake of simplicity. The next step we'll go to is we will remove the roping sheave, the ignition, point cam, and then get to the flywheel. We'll just take those apart, and we're going to get to the flywheel to check the flywheel weight. Now we'll take this over and we'll weigh the flywheel. Well within spec. This is a typical weight that I expect. There's a min. I've found very few flywheels ever at min. Cylinder head. What is this switch, man? 365 would be max. 2.3. Here we have a Model 80 head, and first we do a quick visual. If you look, you can still see the machine marks. As we all know now, we've passed rules that allow us to remachine this because these parts are very hard to get. But there are dimensions that we hold to keep the motor within specification. And believe it or not, we did one earlier, which was CC's. That helps keeps the combustion chamber tolerance, and the head is a major component of that. So now the way I measure these, there's many ways of measuring the rest of these dimensions. I use a level surface plate, and we'll set the head on the level surface plate, and then I'll measure the rest of the dimensions. I have an inclinometer. You just kind of tilt and it gives you various degrees. And what we'll do is we'll set this on the squish band to come up with a squish band angle. Okay. And then last we'll come over here, and there's a diameter that must be met. There has to be a detectable edge, which this one has, and we'll set this in there. I already have it set at max, so we already know we're in good shape. This comes out just about a standard bore motor, which is just fine. So this head now is within compliance. The next thing we'll do is look at the head gasket and measure its thickness. Here we have the head gasket, measuring it with a dial caliper. It's well within spec. It's a standard Yamato head gasket. That's the only thing we're concerned about on this. We're going to come over here now and see if we can get a bore dimension.
Where you at? What you're filming this morning?
And we'll walk over and see if this is within spec. Okay, bore. A bore is a J. And a J. Yeah. This is, as you can see, this is a standard bore motor. We have a dimension for the drive housing. And to do that, we actually have to do two dimensions in the field and a subtraction in order to accomplish this. The dimension is actually center of the prop shaft to the top of the drive housing. However, what we'll do here is I will measure the propeller shaft diameter first, and we'll record it. And then we will take and measure the overall of the drive housing to the bottom of the propeller shaft. And we'll take that dimension. And then we will subtract half the propeller shaft dimension, and that'll give us our O. We take a look at the exhaust manifold visual. There's no real dimensions. We look at to see if there's anything peculiar. This is just a garden variety exhaust manifold. We just, okay, I'll just say this dimension is T. This completes our dimensions of the lower unit, and we've also measured the drive housing. All we have left is the exhaust tube. Okay. First thing we do is take a visual inside the motor, and we're going to inspect the cast areas and the relationship to the steel sleeve. We actually take all the dimensions off the steel sleeve, but you look at the aluminum casting to determine if there's been tampering. It's going to be very difficult to look at. I'm going to try and rotate this so we can get it so I think you can see. If you look down through this port window, you look at the cast down there. Can you see there? What you're looking for, that one's as cast. There's a mismatch between the edge of the steel sleeve and the cast. Looking at this, this looks like this has never been tampered with inside. The next thing we're going to do is take a 1 to 2 mic and come to the upper edge of the exhaust port window, And we're going to measure exhaust port height. Then we'll check the second one, see if it's okay. These I usually check off all the ports, upper and lower cylinder. Of course, I'd be looking at these to make sure they're in compliance. This motor is well within spec. The next thing we would do would be measure block length. And here we've got a block length measurement. Okay. Now we're measuring the transfer port. It's on a bias, so I use a light to get reflection off the corner of my mic to catch the tangent corner of the cylinder to the port. And we got a pencil against it for identification, and at this point we'll try and come up with a determination of length. We've measured now all the ports of this block. We've measured the exhaust ports, transfer ports, intake ports, and are satisfied that they were within dimension, and we'll move on to other block lengths. Here we're measuring the overall block length in dimension A. This is how you would accomplish this easily. There's flats to catch. And then the other dimension we'll catch by taking from this necked corner right here to here. And this gives us our secondary crankcase dimension. Some of these you are forced to split. Some of them you can catch straightforward.
I supervise.
Thank you. The last thing we're going to measure is the tuner pipe. We'll set it over on the surface plate. We're going to measure P, which is the tuner pipe length, as it's two pieces put together. I take a vernier and measure. And being as just come up with a dimension, they give us a 1/16 of an inch tolerance, so this was well within spec. The last dimension we'll make is the opening. Here we have the last dimension we're going to do, which is the OD of the tuner pipe at the base. And they give us 50 thousandths tolerance on this dimension. Pipe's well within tolerance. The last thing we'll look at is the water inlet holes. And for this to be done, an inspector really needs a known legal housing. They're old. I was able to pick up a couple of housings. One of them was a Model 80 housing, and what I do is use it to compare the water inlet diameters and the water inlet angles. You just imagine, just slide a drill bit in the hole to kind of give you a visual on the angle to see if they haven't been tampered with. Then you come over to the known one, and it gives you approximately the same angle. This one's a little bit bigger, but at least you know that they have not been changed angularly. This drive housing would be legal. First of all, at Nationals, I would ask the manufacturer or his representative to bring me a new piston, and I could compare the new piston to the piston in question to discern legality. The second point of issue is on a Yamato, they have what they call block drains here. The block drains have no dimension. However, they must be there, be present, and be free. We would like to thank Buddy Byers and the APBA Historical Society for their support of this project, and we're hopeful that it will grow and continue. I want to thank Tom Johnston and Tom Rice for their support. Tom Johnston brought in this motor for us to disassemble, and I hope this becomes useful. I want to thank Paul for the video, and I thank the Holiday Inn Perrysburg for their support for this project. Thank you.